All right, so we are planning a quiz on Tuesday over metals in chapter 4 and some of the structure of the ionic compounds. And so we started talking about how those structures were based on kind of the ideas of the close packing that we did with the metals and then fitting things into the little holes. But before we look at that, if you have this, pull this out. I'm going to ask you a question like this on the quiz. I have a couple of extras. So what I'm going to ask you, I'm just going to give you a generic one now, is to find two metals, two transition metals, one in the second row and one in the third row that you think you could mix together to make an alloy.
One in the what, third row?
One in the second row, one in the third row. You're going to mix those together to make an alloy. Second and third transition metal. It doesn't matter which side, they're both the same. But if you look on the big side, so the row with yttrium and the row with lanthanum. Okay. But let's pause there with copper and zinc. They do mix together, but they don't form a solid solution where you can do any ratio. They form stoichiometric compounds. Why? Looking at what's information is there, what makes it harder for them to form solutions? Their shape or their packing, right? They don't have the same packing. Okay, so since they don't have the same packing, one of them wants to do one thing, one of them wants to do the other, and so they can't just, get along to go along or whatever the purpose. Okay, so now looking down in the second and third row. All right, so zirconium and hafnium, I would agree with that. So first of all, they both are hexagonal close pack. What's another thing that we should look at? Well, that is the packing.
They're both at 2.16 and 1.45.
Right. So 2.16 is their metallic radius. 1.45 is what we call the covalent radius, but for metals with metals, it doesn't really matter. So we call that the 2.16. So they're about the same size, which means that they're going to kind of fit into those holes together. Okay, let's look at nickel and titanium. Those are the two elements that in a 50-50 mixture make up the memory wire, the nitinol. Do they have the same packets? So that's the shape in the corner, or right next to the symbol, right? Titanium is which?
They do not.
They do not. So what is that shape next to titanium mean? Hexagonal. And the shape next to nickel? Cubic face. Okay, so those two are usually similar enough that we can get some kind of mixture. They're not way off from one another. But this is why that we have that stoichiometric 50-50 thing going on. What about their size? Okay, so they're within 0.4 of one another, not nearly as close as some of the other combinations. But when we were looking at this before, and in your book, it says, copper and gold are similar, and that's 1.57 and 1.79. So they're not like right next to each other. But that size difference is the difference that it makes to make it snap back into place. That when you are distorting it, you're pulling things out of where is a stress-free situation where everything's kind of nestled, and it wants to get it back into positions where nickels all line up and okay. We can just barely see tin and lead on the main group right-hand side. They do not form a mixture very well. Why not? Yeah, and we should say structure, the different structure. Okay, or packet would be accurate as well. So tin wants to do this tetragonal thing, and lead wants to do the face center packing. So the different packing, and I'm gonna hold this up here. So you can kind of see over, where are we? On this side, tin and lead, very different from one another. Okay, so I will give you some kind of question where I might say, will these two elements mix together? Or I might say, here's an element, find something you can mix with it, something like that. And the two main things we look for are they similar size and do they pack the same? The other thing that we might include in there is whether or not the chemical properties are similar. They don't necessarily have to be similar, but in order for the mixture to be stable, we want them to be compatible. So sometimes we'll mix zinc with something that we don't want to corrode, like iron. So we might coat something in zinc because zinc actually is very easily oxidized. And that way, when something comes along and says, I want some electrons, they're going to go after the zinc and not after the iron. And so that way you can kind of protect the iron of things.